Another example which would be great for using Minitab would be in the area of using the chi-squared statistic. It's probably one of the most useful of the non-parametric statistics. We use it when our data consists of people distributed across categories, and we want to know whether that distribution is different from what we would expect by chance or another set of expectations. We don't have scores, we don't have means, we just have numbers or frequencies. In other words, we have nominal data. Well, let's take an example where we have number of students selecting different majors. And if you see in the data table below, I have pre-med, computer science, English literature, education, and English. And the number of students that selected the different majors was pre-med is 50, comp sci 85, English lit 25, education 60, and English 80. And you'll see that right here below. Now if you needed to use the chi-squared statistic to see if these were actually, was there a difference in the amount of majors chosen due to what was expected, or comparing to what was expected, you could do that. And if there's a total, if you take the total of all these, I believe it gives you 300. If you cut that into 5 categories, you'd have an expected value of 60 for each. But as you can tell, English Lit has a lower enrollment. The highest seems to be computer science, followed by English. Well, let's compute a chi-squared statistic to see what happens. Remember again, you go up to the stat piece above. And in this case, you want to go to tables. Chi-squared is hidden under the tables section. And since this is a goodness of fit test, let's hit goodness of fit. And the observed counts are in column C2. So I type in C2. And the proportions are equal. So if they were different proportions, you would specify these as well. You want to test to see if they're equal proportions. So then we hit OK. And you'll notice it gives you a nice graph showing you the contributed values by category for each of them. And they're labeled 3, 2, 5, 1, 4 in order of how they were entered. But I'll take that out of there. And you have a chart of observed and expected values, which might be helpful. The expected is in orange and the observed is in blue. I'll take that out of there. But here's what I'm getting at. The actual chi-squared was calculated for you. It was a goodness of fit test, and you'll notice the observed counts were given above as we entered below. You have the test proportions were all calculated to be 20% each, and so it calculated the expected to be 60 each. Now, this also gives you the contribution to the chi-squared statistic. What you really want to see is, number one, is what was the chi-squared statistic, and is there a significant difference between enrollments among the different majors? And since the p-value is low, the null must go. And so in this case, it's 0.000. That means there is a significant difference between majors, and all the chi-squared tells you is that there is a difference. Now you'd have to go back and see which one's causing the most difference. Well, it looks like the third category, English literature, followed by computer science at 85 for observed, is causing some of that major contribution to the chi-squared stat. That's all you do though. It's pretty easy using that stat function above and then going into the respective statistical model that's needed. Hope that helps. Let me know if not.